Hey everybody, in this video we're going to talk about solving percent problems with proportions. So remember there's three different types of percent problems you can have. You can have ones where the part is missing, ones where the whole is missing, or ones where the percent is missing. So an example of a percent problem where the percent is missing is this one where there are 25 children in Mr. Smith's class and 14 of them are wearing red today. We want to figure out what percentage of his students are wearing red. So, to solve this with the proportions method, you're going to set up two fractions that are equal to each other because that's what a proportion is. So, we'd say, okay, well, on our first fraction, let's write down the actual numbers that we were given. So, there were 25 students total, so that will be our denominator, and 14 of them are wearing red. And we want this fraction to be equal to a ratio with 100 in the denominator because that's what a percentage is. It's just a standardized ratio with a denominator of 100. And there's many different ways you can get this missing percentage that we're trying to find. So in this case, it seems like it would be pretty easy to just say, okay, well, we know that 25 times 4 equals 100, and 14 times 4, if I do that in my calculator really quick, but with your students, you'd want to have them do it by hand. That tells us that the missing percent is 56%. And so we know that 56% of his students are wearing red. And the way that I figured that out is just by finding an equivalent fraction using the same ideas from our videos last week. So you would kind of think about this as a circle that's split up into 25 pieces, but that's a lot of pieces, so I'm not going to draw them all. And then you would split up each one of them into four little pieces. And the 14 pieces that were shaded would also be split up into four little pieces. And so you would get 56. And by the time you introduce percents to your students, they should be really familiar with fractions. So you probably won't have to go through and explain all of that. But if they don't understand why they multiply the top and bottom by 4, you can show that visual again. So that's how you can find the missing percent with proportions. The basic idea of using the proportions method is to set up two fractions that are equal to each other and find whatever is missing. And you would apply a similar process if you were solving a missing part problem. So let's say that Molly's business brought in 15% more revenue this quarter than they did last quarter. If the revenue of Molly's business was $230,000 last quarter, how much did they bring in this quarter? So we're comparing this quarter's revenue to last quarter's revenue. And so that means that the amount that we made last quarter, which was the 230,000, that's going to be the whole that we're comparing um, to the amount that we made this quarter. So that's going to be equivalent to 100%. And we know that Molly's business brought in 15% more revenue this quarter compared to last quarter. So you can either solve this as finding 15% and then adding that to last quarter's, or another way to do it is you can say that Molly's business brought in 115% because it brought in all of the revenue from last quarter plus 15 more percent. So I'm going to solve it this way, but some of your students may like it better if you find out what 15% is and then add that to the 230,000. And either way will get you the same answer, but I'm going to solve it this way. So to find the missing part, we want to figure out what this missing number is on the top of the left-hand fraction. So when we look at this, I notice that if I do 100 times 2,300, that gives me the 230,000. And so if I multiply the top by 2,300 as well, that will give me what my missing number is. So if I do 2,300 times 115, that tells me that the missing part or the revenue that they brought in this quarter is $264,500. And so this would be my answer in this case. And again, you could solve this by just finding 15% and adding it to $230,000, and you would still get the same answer. And so that's how you would solve a missing part problem with the proportion method. And then the last type of problem we can solve is a missing whole problem. So in this case, we have 30% of the students at Walden Elementary have had PE today. If the PE teacher has taught 168 students today, how many students go to Walden Elementary? So to set up our proportion or our two fractions that are equal to each other, we'll have 30 over 100 as our percentage fraction. And then the PE teacher has taught 168 students today, which is the part of the entire student body. So 168 goes on the top because that's equivalent to the 30% of the students who had PE today. Um, and then we're looking for the missing number on the bottom. And this problem is a little bit more difficult than the problems we've solved on the last two slides, not because the whole is missing, but because of what the numbers are. Because if we were to solve this problem the way that we had solved the last two problems, we would figure out what you would need to multiply 30 by to equal 168. But that number is not a whole number. And in this case, it actually wouldn't be terrible because it's just a small decimal. I think it's like 5.6. But there are some times where the number will be a repeating decimal, which makes it much more difficult to calculate. So if the numbers don't work out nicely to do the equivalent fraction method, you can also use the cross multiplying method. So the idea of cross multiplying is that you multiply by both denominators or both of the bottom numbers to make it so that you don't have fractions anymore. So I'm going to put a question mark here because that's what we're trying to find. And if I multiply both sides of the equation by 100, that cancels out the denominator of 100 on this side. And if I multiply both sides by the question mark, that's going to cancel out the question mark on this side. And so we get 100 times 168, which is going to give us 16,800, equals 30 times our question mark. And then you can find that question mark by dividing both sides by 30. So if I do 16,800 and divide by 30, that tells me that my question mark is going to equal 560. So there's 560 students total that go to Walden Elementary. Now, this whole process involves a lot of algebra, and at the time you teach it, your students don't know algebra yet. So you may choose to skip all of this reasoning, which is why cross multiplying works, and you might just teach them the trick that you multiply diagonally across the equal sign. So, like 168 times 100 gives you this number, 30 times the question mark equals this number. And they should understand multiplication and division well enough to know that if they want to find this missing number, then they just need to take this number and divide by 30. So that's another method you can use if the numbers don't work out nicely to find equivalent fractions. So that's how you solve percent problems with proportions. If you have any questions, let me know.